Hi everyone, this is yours truly, Lady Emmanuel, coming to you with part three of multiple transformation of the quadratic parent function. I made a blooper, so I started over. It's the highest graph of f of x equals x squared, which is the parent function for quadratic, transformed to produce the graph of g of x equals 2x squared minus 5. What I automatic notice is that you have x squared here, meaning that's the parent function. What are we doing to x squared to create this new function? So I'm looking at the coefficient. If you look at the coefficient here, which we call A equals 2, meaning that A is greater than 1. Okay? When A is greater than 1, this produces vertical stretch. Okay? When A is greater than 1, you're going to have a vertical stretch, and the A is 2 in this case. Okay? If A was between 0 and 1, then it would be a vertical shrink, okay, compression. So I noticed that first, that's a vertical stretch. Then I noticed that, and guys, go back to your previous information that you've learned with the transformation. And I noticed next is that with 2x squared, it is being shifted down by 5. So when this portion here, the negative 5, this is the graph is shift down 5 units. Okay, it shifts down 5 units. Shifts down 5 units. Okay, and if you go back to your lesson when if you go back to lesson 32 about the stretching, which you guys supposed to read through and do it. If you have read this, it tells you, it said the change to the parent function in item 1 is a vertical stretch by a factor of 2. So go back to 1 and look at that information here. And then it tells you about the factor of 1/2, and it goes on. It said for a greater than 0, how does the value of a in the equation g of x use ax squared change the graph of the parent function? Meaning that they want you to compare this, which you already should have done that. Just notice what you done, what you said. What happened to these graph when this was 2? What happened when you graphed that 1/2 x squared on here? I didn't graph it for you. You should have graphed it. What did you notice? So it's just helping you to summarize what you've learned from the previous problems. Also, number 5 is talking about the transformation of it. So, and that transformation came from lesson 31 when we were shifting the graphs up and down. So here, and this was on number 6 from lesson 31. When you notice that the x squared plus 3, that plus 3 shifted the parent function up 3. Look, there was a plus 3, so it shifted up. Now, if you, well, you should have done this one just as well. Number 7, the same lesson. The minus 4 here, when you subtracted 4 from the parent function, it shifted that graph down 4. So you're taking all this information and we're doing multiple transformation, and we're just basically you're summarizing everything you learned. We're putting together and see could you identify it. Okay, so this is just 2 lessons put together. Okay, so now on number 5 it says use the transformation you described in the item 4 to graph the function. Okay, so you do the same thing. If you think about it, this 2x squared, you had that information in the other graph. So you can go back here, go back to lesson 32. If you go back there to lesson 30, when I said lesson 32, right here it says lesson 30-2. Okay. If you go back to that, you will see that you have, I'm going down to, you see that you have your value for 2x squared. So you take that and graph that first. So we got negative 2a, negative 1, 2. Negative 2a. Oh, now I got to go back to it. Wow. So you got negative 2a. That's off. Okay. Then you have, and you just go, maybe I should have just had this like this, or just tell you, just take the information and graph it, okay? Take the information and graph it, and I'm going to try to graph it at 7 minutes, though I'm going to stop. I'm trying to just show you how I would do it, but I should have separated the page. Let me do this for you guys. Look, you see, I just went on, pulled it out, so I can have it right here. So I have -2, 8. I have -1, 2, -1, 2, 0, 0, 1, 2, and then the 4, 8. And that's going to go off. So here we go. Oh, my graph's so cute. And I'm going to put here 2x squared. That's what that is, 2x squared. Okay? And you'd be like, what about the parent function? Go ahead and sketch that parent function on there. This is not the parent function now. This is not the parent function. This is just the 2x squared. And then once you get that 2x squared, then to graph the other part, just take the points and move it down 5. So this is a point on the graph, so I'm going to move it down 5. I'm going to say 1, 2, 3, 4, 5. Put a point there. Here's another point on that graph. Move it down 5. 1, 2, 3, 4, 5. Put it there. Same thing with this point here. Bring it down 5. And then sketch that graph. And I will have now this graph here will be your lovely, trying to sketch it cute, trying to be pretty. You're done. This is the graph, okay? And we're done, guys. Thank you.